In this video, we are going to discuss about the dynamic sensor characteristics. So by the end of this topic, the students will be able to understand the dynamic characteristics of biomedical sensors, and also they can able to explain the important parameters such as speed of the response, and they can measure the lag, fidelity, dynamic error, overshoot, settling time, damped oscillations, rise time as well as the fall time. So here in the introduction part, dynamic characteristics means it actually describes the behavior of a measurement system. When the input quantity changes with the time also, it describes how the behavior of a measurement system is. So unlike static characteristics which deal with the constant or steady measurements, this dynamic characteristics explain how quickly and accurately a sensor responds to changing signals. So these characteristics are very important in the biomedical applications because physiological signals such as ECG, blood pressure, respiration and temperature vary continuously with the time. So this important dynamic characteristics are measured by response of speed of response, measuring lag, fidelity, dynamic error, overshoot, settling time, damped oscillations, rise time and fall time. So these parameters will help in evaluating the performance and accuracy of the biomedical sensors. So speed of response is actually defined as the rapidity with which a measurement system responds to changes in measured quantity. In simple words, it indicates how fast the sensor reacts when there is a change in the input signal. A sensor with high speed of response provides quickly and accurate measurements. For example, in patient monitoring systems, sensors must respond rapidly to sudden changes in heart rate or blood pressure. Therefore, speed of response is considered as an important factor in biomedical instrumentation. And fidelity. So, here measuring lag is the delay in the response of the instruments when measured quantity changes. That is, it means the sensor does not respond immediately to the input change. There are two types of measuring lag. One is retardation time lag, and in this case the response starts immediately after the input changes but the output increases slowly. But in the second case there is a time delay lag. In this case there is a deadline before the sensor starts responding. So measuring lag should be minimized in biomedical sensors to ensure accurate and timely measurements. And in the case of fidelity, it defines the ability of measurement system to reproduce their changes in the measured quantity without any distortion or without any change in the dynamic error. So a sensor with a high fidelity accuracy follows the variation in their input signal. In biomedical engineering, high fidelity is very important while recording the signals such as ECG or EEG, because even small distortions can affect the diagnosis. So this fidelity indicates the accuracy of the sensor during dynamic measurements. And dynamic error. So dynamic error is the difference between the true value of changing the quantity and the value indicated by the measurement system. So this error occurs because of the sensor cannot respond instantly to the rapid input changes. We call that as measurement error. And dynamic error affects the accuracy of the biomedical instrument, especially during fast changing the physiological conditions. So reducing the dynamic error is more important for obtaining the reliable measurements. And in the case of overshoot is the maximum amount where the output exceeds the final steady state value. So when the sensor responds to sudden changes, means the output may temporarily rise above the correct value before settling. So this extra rise we call it as overshoot. If large overshoot may produce incorrect measurements and instability in the biomedical systems, then this overshoot should be controlled for proper sensor performance. And in the case of settling time Settling time is the time that is required for the output of the system to reach and remain in the specified tolerance range, that is around the final value. So in simple terms, we can tell that it indicates how long a sensor is taking to stabilize after a input change. So short settling time is preferred in the biomedical systems because quick stabilization may help in faster and more accurate monitoring of patients. And in the case of damped oscillations refers to the gradual reduction in the amplitude of the oscillations when there is a energy loss. When the system oscillates after a sudden input, the oscillation slowly decreases and finally it stops. So this reduction is caused by damping. If proper damping is actually necessary in biomedical sensors to avoid the continuous oscillations and unstable readings. In case of rise time, that rise time is the time that is taken by the output to increase from a lower percentage to a higher percentage of the final value, usually from 10% to 90%. It actually represents how quickly the sensor output rises after an input signal is applied. A smaller rise time means faster sensor response. So rise time is also an important in biomedical monitoring systems where rapid signal detection is necessary. And the next one is fall time. So fall time is the time taken by the output to decrease from a higher percentage to a lower percentage of the initial value, usually from 90% to 10%. It indicates how quickly the sensor output decreases when the input is removed or it is reduced. So fall time helps in analyzing the dynamic behavior of the sensors while decreasing the signals. So in the final part, this dynamic characteristics helps in understanding how biomedical sensors behaves when the input changes with the time. So parameters such as speed of response, measuring lag, fidelity, dynamic error, overshoot, settling time, rise time and fall time, these are the major important parameters for evaluating the sensor performance. These characters actually ensure the accurate and reliable measurements in biomedical applications. Thank you.